In this video, I'd like to consider the problem of taking a table of values, such as we studied yesterday, and actually constructing a formula for f of x based on the stuff that we're seeing in the table. So, first example, let us look at the first table from yesterday, where we analyzed the pattern in the y's row, and we deduced that based on the pattern that we saw, the growth was linear, and the slope of the growth was 3, because we added 3 each time. And what was the y-intercept? We found that the y-intercept was 1. So let's find a formula for f of x. Now, the way that I like to approach this kind of problem is I like to start with the general formula for a linear equation. So f of x was linear. We concluded that it was linear because we were adding a consistent amount each time. F of x was linear, so it has the general form f of x equals mx plus b. And remember, I am actually going to change plus b to plus a. Even though it might seem a little bit less familiar, I think the notation is more consistent with the notation that we use for exponential functions. So I'm going to call the general slope-intercept form of a line mx plus a. And remember that m was the number that stood for the slope, and a was the number that stood for the y-intercept. So all that we have to do is fill in the m and the a in the general formula with the slope and the y-intercept from our problem. So let's scroll up and remind ourselves that for our problem, the slope that we saw in the table was 3. And for our problem, the y-intercept was 1. M equals 3, a equals 1. Slope of 3, y-intercept of 1. So, if we fill in the blanks, here is our formula. The function's formula is 3 times x, slope times x, plus 1, plus the y-intercept. This would be the formula for the function that is being described in this table. Okay, let's consider the second example from yesterday, and let's once again try and find a formula for the f of x that's being described in this problem. Now, yesterday we analyzed this table, and we observed that it grows exponentially with a base of 2 and a y-intercept of 5. Now, once again, I'm going to start with the general formula for exponential growth. I'm going to say f of x grows exponentially, so it has the general form f of x is equal to some number a times b to the power x, where the b stood for the base and the a stood for the y-intercept. Okay, so for our problem, we had a base of 2, if I recall correctly. Yep, base equals 2. So b is 2 for this problem. And we had an a value of 5. We had a y-intercept of 5. So if I use these numbers to fill in the blanks, I get the following formula. F of x is equal to 5, the a value, times 2, the b value, to the power x. And this is the formula for the function in this table. All right, now let's consider the third example from yesterday. The third example, we concluded that the growth was exponential. Exponential with a base of 0.8 and a y-intercept of 2. So once again, I'm going to go ahead and set up the general formula for an exponential function. General form for exponential is f of x equals a b to the x. And I'm going to fill in the blanks with the numbers that we have. We have a base of 0.8. And we have a y-intercept of 2. So f of x equals 2 times 0.8 to the power x would be the formula for f of x.